Hey everybody, we're back. It's been a week or two. Went through the milling machine and have cleaned it all up, painted some areas, and then I've got it partially reassembled with the motors on it at this point, because you can't put the top on until you get the boxes on. This thing has to go together a specific way, or you can't put the box covers over the drive motors or servo motors. Had to make some special mounts because of the motors. I got plenty of them. I have a whole bunch of these 24 volt servo motors. They have excellent torque. I had them run the machine that's behind me here when it was CNC, and they'll be more than adequate for this machine. They're a little bit large, so I had to make some NEMA 23 plates for it and actually go through the motors and machine a portion of the face in order to be able to use screws to mount the NEMA 23 plates onto the actual machine itself. We'll kind of go over it. I'll show you what I got, and then we'll go over some of the electronics that we're going to do. I'm going to break these videos down into small segments of working on separate sections of the machine, and so it'll keep them short. But anyways, we'll go over the machine, kind of show you what I got. I kind of still have my shop torn apart because I have everything, all these parts all laid out on things and getting with paint drying, etc. And not to mention I have a whole bunch of motorcycles in here that I'm working on as projects. So anyways, we'll go over this and we'll show you what we got. That's it. All right, so here is the y-axis. I went through and I've already cleaned all the rails, lubed up the ball screws that was on it, tested all the limit switches. These are the leads that go to the limit switches. These are my servo motors. These are 24 volt. They have like 350 or 390 ounce-inches of torque. I'm running a US Digital EP2 250 encoders on it. This is the encoders that I had on the other machine. I have desoldered the wiring on here. The new electronics uses a different system, so we'll go over that in a little bit. So I have to get all the wiring ran into here. That's going to be the first segment of the video, is getting all the wire ran to the servos. New belts on there. The pulleys, everything's already tensioned and tightened up. And as you can see, I had to machine these little pockets out of the face of the actual motor so I could put these screws on here. As you can see, they're just a fraction tall, but they'll still fit inside the box, so plenty good for that. I've ran these with a battery using the leads on the motor. A 12 volt battery, still plenty fast enough. So same thing here. The x-axis is all done, same encoders. I got I'll tell you a little bit about it. I'm using a Pour 15 top coat paint. This is the safety blue, and then I had the safety white, and I bought a small pint of black and I mixed it in to give myself a light gray color for the inside and the outside of the top cover, which I think I have. Yeah, I have it out here. We'll cover some pictures on that whenever I get ready to put this thing on here. But the covers, these were boogered to get clean, and as I noticed in the beginning of the video, the machine had dried out coolant in here, and let me tell you, that was a pain in the butt to get out. I tried scrubbing these strainers. That was a total pain. Soaked them. It didn't matter. I could not get that stuff out of them. Actually, the little tiny holes in the strainer I could not get clean. So I actually soaked them in some Purple Power and let them set for about an hour. And then I took my pressure washer, and that worked. So I was able to get all the holes cleared out in the strainers. If you see a little dirt in here, it's because I've been cleaning this section a little bit more. I didn't want to move any of the axis until I was able to go through and clean them up a little bit, clean the threads on the ball screws, and then apply some new oil, move it in the direction that I got cleaned, and then do the same thing on the opposite side. Same thing with all X, Y, and Z. So those are all done. I have the top section of the spindle all torn apart. I'm really hoping that there's nothing wrong with the motor. Because if there's something wrong with the motor, then I'm going to go with an AC servo motor, probably a 1 kilowatt AC servo motor, which those max out at 3,000 RPMs. And I'll have to try to figure out how to redo the pulley section because it's very, very tight in there. And you can see that's the pulley that goes on the motor, and it uses one of them serpentine, multi-groove serpentine belt style pulleys on it. And there's not very much room in there to be able to get myself a 3-to-1 ratio to give me at least close to the RPMs that this thing had before. Like I said, I'm going to do a lot of machining of small parts with small bits, so I prefer the higher RPMs. So if I went with the 1 kilowatt, which is about 1.5 horsepower, the 3-to-1 would probably make up, versus this is like 3/4 to 1 ratio, because the motor is 7,200 and it was giving it a 10,000 RPM spindle speed. So the motor had the bigger pulley on it and the smaller pulley on the spindle. I have the TTS Tormach style collet system that's going to go on here. That'll get rigged up for the ATC that's on here. I bought a brand new pump, the Little Giant pump, and it's all connected with the hose and everything. All the fittings are back in. It's all mounted, so that's good there. The drain line back here, I still have to, actually when I took this thing apart, I broke this PVC fitting. Luckily it's just a standard 1.5" slip to MPT thread, so I just go buy another one at the local big box store, Ace Hardware, whatever. So replace that, so I'll be able to put that all back on there. And again, the Z-axis was done the same way. These are the limit switches, new belts, everything's good. Like I said, everything's been drove in and out. I had to put new feet on the actual thing. So what I plan to do on this workbench is I'm going to get some pipe, cut them in half, and weld to a plate so I can put some foot locks on this bench, because this machine will be able to go, upwards of 200 inches a minute. Not that it'll ever machine that fast, but it's a lot of weight shifting forward, back, left and right, up and down. So I don't want this thing to walk off the bench. Even though it's got brand new rubberized feet on here, I'm still going to make some method of locking it to keep it from shifting. The machine is very, very heavy. I said this is upwards of 700 pounds when it's complete. So anyways, I'm going to set up my camera. We'll go over my electronics. I have a whole barrage of stuff laying here. This is for this project. I still have things rolling in, small things at this point, but I wanted to go over items that we have. Start out with, I bought a mini PC. It's one of those small brick style PCs, Windows 10, all that kind of good stuff on there. Nice and small, so it'll fit in there inside the actual electronics chassis. So get an idea. It's what, like 5.5 by 5.5 square, really small. And HDMI, it's got Ethernet connection, USB connection, really, really light. So that's what's going inside that on this thing here. So it has its contained unit, so I can install Mach 3 on there. Anyways, that is that. I happen to have a 24 volt power supply. It works. This is a switching power supply. It's rated 24 volts at 13 amps, which is more than ample to carry this CNC system, because when I had the other one, I had a 10 amp power supply on that, and it was more than adequate for it. I have a barrage of Cat 5 cables. The Cat 5 cables is the actual items that I have use Ethernet connection going for my encoders back to the actual servo drives and all the stuff from CNC PC or for PC. So we'll go over that here in a little bit. I'm going to be doing an external monitor system that I'm going to build. I got a 13-inch touchscreen monitor coming in. So, and then I got the e-stop for it, start and e-stop button. I'll need other buttons, etc. later on, but that's basically what those are for. I have my Heyco drives. I have 3 of them. I'll probably add 4th axis to this later on, but at this point I only got 3 drives. So those will be going into the box as well. And those are the the 320X, G320X drives for the servos. I have DIN rails. These are the actual DIN rails that all the DIN components mount to. So I have a whole package of these things to be able to mount inside the box. I'm huge on wire. I have plenty of other wire as far as larger sizes. This was 20 gauge wire. I got an assorted box of colors for some of the signals. Most of the signals will be done with Ethernet cables, but I do have some others for doing separate things. I bought, this is a cable management kit. Got them on Amazon. Most of the stuff, you either got it from eBay or Amazon. You know, the DIN rails, the wire, eBay, cable management kit. It comes with the actual parts with the lids for them and everything. And they got the holes through the side so you can route your wires inside the box and then put a lid over it, and then each one of the holes, the wire can come out into the appropriate position of the actual component that's going to be supplied with the wire. So anyways, I got an entire cable management kit to do that. And then I have a Ferrule Kit. If you're not familiar with the Ferrule Kit, this is what you use to put on the ends of the wires that have terminal blocks. And we'll go over those terminal blocks. They're like the green terminal strips, and they have the flathead screwdriver. So you put these ferrules on the ends of the wires and crimp them on there, and then it gives you a cleaner look when you put the wires into the actual terminal blocks. Most of the wire for this system is going to use really small ferrules, and I was unsure how many red ones is this common size I'm going to use, which is the 18-20 gauge connection. I have a bunch of different smaller ones which will work great, so I bought the whole kit, got it on Amazon. It came with the crimp and everything. It's cheap. And then I bought an extra thing of the red ones just in case I needed more. So that's just the Ferrule Kit for terminating that. And you'll see all these items used as we're making going ahead and doing the assembly with the videos. So, and then we have more DIN rails. The other box here was actually terminal blocks, not DIN rail. These are the DIN rails. Comes with a whole bunch of different rails, and you can mount them to mount all your. You can get relays that use DIN rails, so everything comes off really easy. If you need to get in there and replace a component, you don't have to disassemble with screws and all that stuff. These rails mounted there, and your parts clip onto the actual rails that's removable. And then these are the terminal blocks for running power, grounds, etc. It has jumper pins, so if you need a whole row of them to be for positive power or specific ground or anything, you just put the jumpers in, and you would have a jumper to all the different connectors. So that's that. So we have that, and then now we'll go over the CNC 4PC. Arturo was really great, helped me out through some of this stuff. I mean, he tried to talk me into going to the newer Star servos, but I already had the motor drivers for other project, and I'm just finally put them to use on this particular item. I was going to build a CNC plasma cutter, but I decided to hold off on that because I actually have an actual stepper, cheap stepper system that I'm going to use on that. But this is the box of the stuff that came from CNC 4PC. We'll kind of go over these items. That's the goodies. All right, this here is the I'm going to assume the C82 multifunction board, and it has the Ethernet connection in here. All your motor drives are in here. So we can open this up. I haven't opened it yet. And I got it with the DIN rail backing on it. So you can see this thing slides in and out of this actual DIN rail assembly that snaps in place. But everything's Ethernet connection on here. And then Ethernet from the actual computer comes into here instead of, and this is basically like your breakout board, I guess you could say. But this is the C82, and this particular item will work with my G320X drivers. And then I have all of these go into each individual G320, and there is a part that here, this actually goes into the screw terminals into the G320X, and then this goes onto here like this, and then run Ethernet out to the motor driver, and then Ethernet to here. So basically on the Cat 5 cable, I'll cut one end of the Ethernet plug off and directly solder it to my encoder. It'll come back, plug into here, or one of these ports, I'm not sure yet. And then from here, go back to the breakout board assembly. So that's what these are for. These are for the Gecko style drivers. And there's 3 of them since it's going to be a 3-axis machine. And he includes the Ethernet cables to go back to it. I bought 5-foot Ethernet cables. I bought them on eBay, a pack of 10. It was pretty cheap, so I got 5-footers, so that give me plenty of room to have, you know, I could do cutting, etc. Then this is the ribbon cable. It goes back to the M26X. This is the relay expansion board. Being that my machine has an ATC, power drawbar, coolant system, whatever else that I decided to put on here, this is the relay breakout board to control all of those different functions. So basically this will plug into here, and then it goes back into here and plugs in. And I also opted for the DIN rail mount, so I'll be able to lock that in there. So we'll go over all this stuff. I'll have drawings, and let's say we'll go through how this is going to get put together. And so basically what we're going to do is take these items, the drivers, these boards. I have to figure out how many relay assemblies I need for the different things that controls it, you know, for the relay to turn. This will turn a higher amperage relay for the coolant pump. These relays in here will be more than adequate to run the solenoids that run the power drawbar and the ATC. Those are very low current in the first place. So anyways, we will touch base back. I'll have the box mounts to the back side of this machine, and it's the back wall of the machine. So I'm going to do most of my mounting first, mounting the DIN rails, etc., before I put it back on the machine. So I'll do a placement of where I want everything to sit, and then begin to mount the DIN rails and etc. So I had to drill holes through the back side, run bolts through, and tighten them up to tighten the DIN rails in, because it had welded in studs, but none of that stuff's going to align with my new system on there. So I had to cut them all off so I'd have a nice flat space to work with. So anyways, that is this. What we have is it's just temporary setup. Nothing's bolted down. Only thing that's bolted down is the ATC solenoid assembly. That's done. And I have the motor driver. That's the original motor driver. I do not know its status, so I'm going to go on the assumption that it functions. This is a brushless motor that's in this machine. So I have found that this company is Maneric. They make that they made this drive. They do no longer have this particular drive, but they have one that's relatively similar to it. It's quite pricey, so I'm quite hoping that this is actually working. All right, so I've installed, this is the original motor driver plate that was in here, I can assume, because it had heat sink compound on it and I cleaned it all off. So I'm going to reuse it as the actual motor driver section since the studs are still in place in the box. I have the Heyco drives just basically set up here, so I will add the second or the fourth point for the fourth axis just in case. The wire management tabs. The nice thing is these things have different fittings, so I can literally come in here and route all this stuff in so the wires will stay nice and tidy. It's a full kit. I mean, you can join them together if you needed to make longer runs, that kind of stuff. But I got them in here. I'm mounting the power supply here. The computer will be around in this area here. Basically, where all these holes in the back side, I have to watch covering them up because there's physically functions that go towards the machine, such as the power from the coolant pump comes back, the x-axis comes in through here, and the y-axis, the z-axis comes in through the top, so no big deal there. All these original holes were breakers. I'm going to try to reuse those breakers for these particular functions. And then what I do not use, I'll get plugs and cover them up. So for the most part, these main holes, these air hoses come through for the ATCs in here. And there's also another hose that comes out and then goes up to, or two more hoses actually, that come up and go to the actual, what do you call it, the drawbar. So the PC, I potentially trying to decide if I want to take it out of the case. I may or may not. There is a cooling fan, looks like a little cooling fan right here, but it will set in this position, and I'll orientate it so that none of the plugs are interfered with putting up against the wall. Like I said, I'm going to put a remote switch which will come out and go to the console that actually drives for the function of the machine, or the interface for the machine. So I'll have a remote switch to turn the PC on from externally. The C82 and the M26 relays, like I said, they're all DIN mount. I'm going to order my DIN mount relay assemblies that'll turn, I don't know, I haven't looked to see what these are rated for, but I don't think I want to use these to actually turn on my coolant pump, etc. Because if the channel fails, then I'm kind of hosed because of the current draw. The actual coolant pump only draws 1.7 amps, so I'm going to look to get another DIN rail relay assembly, single pole, single throw, or double throw. I'm not sure yet. To mount on here to turn the coolant pump on, to be able to have a button to manually, I don't know if that'll need to go in the relay, it might just tie into here, to be able to do the drawbar manually, so I can take the tool out manually if I needed to. The power comes in from the bottom here, so it'll tie up and go into all these relay assemblies. Like I said, then I'll have all the wire management through here. This is basic layout of what it's going to be like. So basically I just got to go through and drill lots of holes and mount all these components to the actual DIN rail, to the panel itself, and we can move forward to get this onto the machine. So without further ado, we'll stop the video. That'll be the end of this video series, or this episode. And when we come back, I'll have these things mounted, and we will get it mounted to the back of the machine, and then that way we can start breaking down segments and wiring them independently with separate videos. So stay tuned. Please like and subscribe, and we'll see you on the next video. See ya.